All right, so welcome to the webinar today. And the topic of our webinar today is going to be preparing and optimizing 3D models, mainly for the purpose of web configurator and of course CET designer catalogs. First and foremost, does everybody see my screen over here?
Yeah.
All right, perfect.
Yes.
So I'm gonna stop my video over here and we're gonna get started. So basically, for today's webinar, it's gonna surround the work before you put in the models into Model Lab, a little bit of preparation work and optimizing work, and we'll go into Model Lab a little bit as well. So first of all, I'd like to introduce myself. My name is Shijia. I think most of you, some of you has met me before in training or in CET user conference. And I worked in the Configura KL office and have been using Catalogs Creator for more than 5 years now. I do catalogs training and business development in Configura, at least the Asian market. So, all right, so let's jump right into it. I understand a lot of you here are users of Catalogs Creator, and some of you are in charge of making the 3D for your company. And first, I'd like to introduce our CM-Sim format. Some of you might have started when we were using the CM3D format, which is our older format, which we are still going to support moving forward. But I would like to introduce this CM-Sim format. It's a new standard. We are trying to establish that, and we have already supporting catalogs for this format. And if you're aware, we have a built-in conversion tool that allows you to convert all the reference in Catalogs Creator to CM-Sim and automatically batch convert your currently available CM3D into CM-Sim. And one of the main reasons that we are introducing this format is to introduce the stretch function, which you are going to see this minor release, 11.0 minor release. And our web configurator too is also built around CM-Sim. We are not supporting the CM3D format for the web configurator. So if you like to use the new web configurator solution, please do convert your CM3D catalogs into the CM-Sim format. And not too different from the CM3D format is that it's a mesh model. It involves vertices, edges, and faces, things like that as well. So from the outlook of it, it doesn't look too different from the CM3D, especially when it comes to the creator's work, but the backend is improved. The file is smaller than it used to be in CM3D, and there's better support for hierarchy and as well as UVs. As we do have big group here, if you have any questions, do feel free to, do we have a raise hand function in Zoom? Or you can just type it into chat as well. I'll attend to it if I do get any questions. All right, so everything that we are gonna do today, basically the output that we're going to have is in CM-Sim format, and we'll be concentrating on that as well. All right, so before we go into really the steps and a few suggestions from us and how you can really optimize the 3D models, I'd like to explain the concept for Polygon budget. So if you are a Model Lab user, you're probably very aware of the LOD system that we have in place. So if you're just a 3D artist, let me introduce you to our catalogs CET Designers Model Lab. So basically, this is the tool that we use to import 3D models in CET and convert them into CM-Sim format. It used to be CM3D, and now we are introducing CM-Sim, which has been quite a while. So we have what we call an LD concept here, and you'll find it on the left under level of details. That's what LD stands for. And what we call polygon budget is for every symbol. There is a budget that we allow in each of these LD. And when you click on to a certain LD, you will notice my viewport changes based on the distance. So at this distance, CET uses something like that. And if it's in medium, it gets more detail. And we have the tools and function to basically generate all this in ModelLab. One thing to note is that the web configurator only uses the super LD, and this is also only used in rendering in CET. So for every model, which is every model is different, we have a different budget. So for this one in particular, we have a base, which is the original imported file. In this case, it's about 15,000 triangles, and in super, yeah, so the super is actually about the same as the base, as this is a pre-converted file. And you'll notice in high, we have a polygon budget of 3,000. So if you go above this number, you start noticing the green color on the high button, which should switch to yellow, and the higher it goes, it changes to an orange and eventually a red. So a red indicates that it's way over the allocated budget of this on this particular LOD, where it's going to use in this distance. So going back to the slides, so there's actually two criteria for that specific model where the budget is allocated. It depends very much on the volume of the model as well as the surface area. So these are the two criteria that is taken into consideration when we are basically ModelLab allocates the polygon budget. So if I were to jump back to ModelLab really quick, and let's grab something. Let's grab this symbol. This is a bar stool, courtesy of OFS. We're using this as a real life example, and you get something like this, and everything is in red. This is most likely the case that you've come into when you import something new. And what you do is you click on Run All. So if you were to resize this to say about this size, yeah, maybe this is a bit too much even for this size. Yeah, let's take the original chair. So we have this chair, which the base is about 15,000 triangles, and if it's any smaller, everything is in red. So it very much depends on the size. So let's say if it's half the size, the polygon budget that is allowed is now very much reduced, and it's, if I'm gonna run it again, I'm getting about only close to 4,000 for super, and you can see that it's much less detailed than what it used to be. So for those who don't know, starting from 10.5, we added the undo feature in ModelLab. So now you can hit Control Z to undo. Okay, so however, this itself, the polygon budget is a guideline that we at Configura actually try to put in. It's not a strict rule. That means if you're over the budget, it's 100% fine. We do, however, restrict the upload of something that is more than 100% of the budget itself. So Ultimately, a better judgment of whether the triangles is too much or is up to you yourself. And I would say these are the few criteria that you need to put into consideration. So first, of course, when we are talking about Polygon and Polygon budgets, the main purpose we do this is due to performance. We want things to run smoothly, whether it's on CET or whether it's on the web configurator. We want things to load fast. We want things to be responsive. So that would be the main criteria. We do have the QA tools to detect this. The performance tracker, the response monitor, those are a few tools that you can use to quickly check if that's a good response time when you pull out the snapper from catalogs, for example. And the second criteria is the quantity in the drawing. So this very much depends on the nature of the product. So if it's a special feature, if it's a reception desk that is very grand, and it's most likely you're only going to have one of those in your drawing. So having it at a higher end of the polygon, it's fine. You might want to conserve the details. That brings me to the third criteria. You might want it to look better than the others, but that's only going to be one in the entire drawing. So for that, you might opt for more triangles. You're not going to put 1,000 of them in the drawing. But for something like a chair or something like a work surface, for example, you don't want 1,000 polygons for desk, because that's if you're going to put 1,000 of those in CET, you're going to struggle with performance. So it's a balancing act between these criteria. And
in a minute, Jim got the job. Doofus, buffoon, Jim, Sarah just found out. She's devastated.
Do we have a question?
Said, get a mask that has a train on it. She said somebody put a calendar in this, a train calendar, and he went around like a little kid.
I think someone just didn't mute.
Okay.
Okay. Yeah. So if you have a question, please you can voice up. And yeah, so back to the polygon budget. So like I mentioned, be reasonable on the polygon counts. The model lab rates looks like it's dangerous. So don't be too concerned about this. If you know exactly what you're doing, please feel free to go over the budget. Just be reasonable about it. You don't want 50 times, 100 times over the budget. And of course, computers nowadays are getting better each and every day. So this will be less of a problem moving forward. But of course, for us software developers, we want performance to be good on more computers, not less. So yes, so that's the entire idea of the Polygon budget. And back to web configurator before I forget. So web configurator, it loads up only a single model each time. But the consideration here is we are gonna use the same CM-Sim model for both web configurator as well as CET. So in this case, we might want the performing model in CET, but something that still looks good in web configurator. That's of course one of the purpose today. We are trying to balance this out so that you don't have to have a duplicate model or duplicate catalog for CET and for web configurator, which is of course originally one of the selling point of web configurator. You can maintain one set of data and have it on both platforms. All right, so let's jump into it. So typically today, when we get a model from manufacturer, whatever it is, most of the industry, we are starting with a solid model. This is of course the nature of the industry, the business. We usually start with the R&D of the product. So those are usually done in softwares like AutoCAD, Inventor, SolidWorks, and those are solid-based modeling. And it's rather different from what we used, which is mesh models, and mesh models we share the same if we share the same vertices and triangles concept like those in 3D Max and things like SketchUp. But typically when it's coming to whether it's material handling or the commercial furniture industry, the files that we use as a source is typically a solid modeling. So of course we have dealt with 3D Studio Max STL files like that before as well, but most of the time it's a solid model. So, and these files are designed to be manufactured. They are the files that go into mold making. They are the files that goes into jig, things like that. And it's usually much more complicated and complex than it needs to be for our purpose. And our purpose in our community is to basically make symbols for space planning, in this case for CET designer, and of course for web configurator. So both of this, we don't really need the manufacturing model to be in the platform itself. But that usually is our starting point. So I'm going to show you a few ways of preparing these models. We might not have a lot of choice. If you want to start somewhere, we have to start with these models. So I'm going to show you a few tips and tricks on how we handle preparing this model before pulling into Model Lab. All right, so the first tip is basically removing all the non-visible features. So I'm going to use a CAD software to demonstrate this, and you can use any software that you're using, be it AutoCAD or SketchUp or whatever 3D modeling software that you're using. So the concept applies to any 3D software. So I'm just going to pull out the file here. Okay, so this is the modeling tool that I use. This is Rhinoceros, but like I mentioned, it doesn't really matter. What I'm explaining today is more on the concept of things rather than the tools. So yeah, the first tip is basically removing all these non-visible features. The few examples are the hidden parts. You might have something that is hidden behind an upholstery. Remove those. You might have something that is a spring or something inside the mechanism of a chair, for example. Remove those. You can remove mechanical ribs, thickness, holes, and fasteners. I'm going to show example for each of these cases. And starting with hidden parts. So there are parts that are hidden inside your models, and very likely you don't even know they notice. You don't even notice they're there. So take for example this bar stool. So this is the seat. So right underneath the seat, there are parts like this with a lot of features. And if I show everything over here, there's something you don't even see. So that's something you want to remove. And this alone can be a few thousands polygons based on the details that we have here. So just delete it before even putting it in CT. Things like metal parts, functional parts inside the model. So these are important when we are manufacturing, but not so much in CET, not so much in web configurator, because you don't even get to see them. So in a sense, the polygon budget is fixed, and if we are not allocating the triangles to these parts that is not visible, we'll have more for important features like this one, which is one of the design feature of the product itself. So these are much less important. You can just delete them even before pulling them into CT. Of course, this can also be done in Model Lab. And some Model Lab is very much a conversion tool. We have limited functions in Model Lab, so it's always easier to just go into a 3D CAD software to actually remove them before importing. All right, so second one is ribs. So ribs are things that add strength to the real physical parts, but not so much the digital one. Our symbols doesn't really get stronger with the ribs, so that's one of the things that adds a lot of triangles to your symbols, but really it doesn't really add much to CT. And one of the main culprits of this is the chair base. Of course, there are arguments that say this is actually one of the design feature. Yeah, I do agree. So it also comes back to the balancing act. If you think this is important, you can have it. And if not, it's just gonna reduce thousands of triangles alone due to how complex this is. So usually for myself, I like something clean. Let's take, for example, this one. Most, I would say 9 out of 10 times, maybe 99 out of 100 times, I'm gonna render my drawing from this angle. And perhaps for web configurator, that is important, that you want user to actually see the ribs itself. So that's the exception that you can make. And even for that, you can have it in super, but not the other LODs. So this is what I always use. I clean it up and just make it a shell. And that alone will save tons of triangles. The thickness. So a lot of these parts, whether it's a racking profile, for example, material, the pallet racking profile, upright profile, or a part like this. Let's say, okay, something like this. This is a part from the bar stool. I mean, from the task stool. So basically, in real life, everything has a thickness. And again, this is from manufacturing. So it might make sense to just remove this and leave it with just the shell. And really, these are things that will be covered by the seat itself. So you won't ever see them. You really don't need the inside part of it. So I would say removing the thickness, you are left with just the outer shell, which is the part which is important for us. So removing it, and you'll notice advantage of solid modeling is that all the surface information are still in place. So it's generally quite easy to select and remove them. But once you actually convert them into a mesh and bring it back to a CAD software, it's much more complicated. So there are advantages working in a solid format. So these are faces that we see, and you can just remove them. So this is what I usually do. I start with where I want it to end, and I remove the remaining connections with the outer shell. And when you explode and rejoin them, it's now split into two parts. I think I missed some parts. Yeah, so basically you're detaching the outer shell from the inner ones. And you're left with this. If I flip this, yeah, so you get a clean shell like this one. So from the outside, it really doesn't look any different. But coming from this to the other one, you notice that it's much less. It's basically close to half the triangles needed for just the external shell. Okay, so let's go back. Right, so we have some question from Steven. Sorry, I missed this earlier. In the LOD, I assume, and upon converting, what is the difference between the mesh reducers, MK and oak? Okay, so that's a good question. Okay, so you notice in ModelApp itself, we have a few algorithms for reducing, basically oak MK, and starting from 11.0, you might see a new algorithm. So these are just algorithms that we use to reduce the polygons. Most of the time, I can't say I know exactly what's the difference or main difference between the algorithm is, because I'm not an expert in this. But for myself, for my usage, most of the time I use MK, which gives me a good result most of the time. But there are exceptions. The oak mesh reducer comes in handy. What I do notice is sometimes when there is a negative space, for example, leg cantilever that is built from steel tubes, that is actually, I get better results with oak, but like 9 out of 10 times MK is better. We are adding a new reducer, seam aware mesh reducer. So this put more emphasis on the edges. So it's technically, it's something very new. So we're also experimenting with it. But this put more emphasis on the edge, on maintaining the edge of the model. So if you're coming from a mesh model as your source file, this will be a good one to try out starting from 11.0. And a question from Dave. Is there any way to control the base model triangle count when the 3D model is originally imported into ModelApp? Share example had 15,000. Similar models have imported rarely have more than 5,000. All right, so this is a good question. So when you have a solid model imported to ModelApp directly, it will be automatically converted. So the solid is going to be converted into triangles. So to overcome this, you can actually pre-mesh it. So this is another point that I'm going to bring up later. So I will jump into that your question, Dave, after this, because I do have a section especially for that one. All right, so okay, so back to my first point, which is basically removing the non-visible features. These are a few things. And yeah, last but not least, holes. So again, holes and fasteners, they add a lot. And I've seen 3D models that have the details of the thread. Each and every fasteners have like detailed threads, and a single bolt is 1,000 polygons to start with. So removing this will very much reduce the triangles. It's not so much that we are gonna in ModelApp generate 1,000 polygons in this, but in a sense, when you remove them, there won't be any triangles that is allocated to the fasteners at all. So the size of it is really small. So ultimately, it might add a few to it, but even bringing that model in requires ModelApp to actually read all this. So a good idea is to just remove them. And there are also functions in ModelApp where you can select by the scale of it and just remove these small components. So to demonstrate this, I am just gonna draw something. I'm just gonna take this. So this is just a surface, right? And I'm gonna make a copy of this. So these are holes for the mechanism. And naturally, we have this when we are sending this to mold making and things like that. But ultimately, it doesn't really affect the outlook of the product that much. But I'm going to remove the holes from this surface, and I'm going to leave this be. And I'm going to switch to a wireframe view. Let's go with shaded. I'm going to remove, let's try untrim or untrim holes. And I'm going to remove all the holes in this surface. So I'm left with a clean surface like this. Same goes with all the other holes that we have in the drawing itself. And yeah, things like this, those are markings for mold or part numbers. And yeah, whatever it is, it adds to the triangle. And we don't want that. So if I were to just make this a mesh, so let's start with high number. And let's start with the same settings. You notice the triangle concentration on the hole itself. So this is quite drastically different. Let's look at the numbers. This simple shape itself is 189. And let's reduce that to, say, 30. You're going to get a decent polygon regardless. If I'm reducing this starts with a 900 numbers polygon count. I'm reducing this to the same polygon budget, in this case 30. So the reduction, these are the elements that are important, the fillet, and this doesn't really know where it wants to locate. The holes doesn't appear nice. It removes all the features from my intended surface. So yeah, so this is the main difference. So you can imagine the same thing being done in Model Lab when you're reducing the numbers. If you have already well defined what features you would like in your final product, it knows to just put those polygons, put those triangles in where it matters. So in this case, yeah, you get drastically different. Let's reduce this again to 30. Yeah, you get drastically different results if you were to remove the holes. Okay, so going back to this. Yep, so this is the original one. If we were to remove all these holes and this one and clean up the internal shell, let's say this particular volume, the polygon budget is 1000. We know exactly 1000 goes into where it matters. So and that makes it look good, basically. And of course, sometimes there are instances or cases that we do want to see the fasteners. They are actually part of the design itself. So if that's the case, I would say please remove this part. You can leave the head. Just remove the, what do you even call this? The spiral part of the screws of the bolts, and just leave the head. You might want to see the Phillips head, and you don't really need to see the hole because that's covered by the head itself. So sometimes, yes, these elements are part of the product and design itself, and sometimes the holes matters as well. Say, for example, the holes for pallet racking uprights, those are actually mounting holes that are important to showcase, but you might want to simplify them into just a square hole instead of a round one. A round one always adds so much more polygons than a square one. All right, so that's the first tip. And the second one is something that, any questions so far on the first tip? can type it in chat or just speak up. All right.
Shijia, everything that you're doing in here from a Rhino perspective, do you know, does AutoCAD have all that same capability?
Yes, they do have it. AutoCAD is more to a drafting 2D tool. It's definitely stronger in 2D sense, but they do have similar commands that do the same thing. For example, what I've shown in Rhino, I include some tips here. The meshing tools, there is AutoCAD commands to do that exact same thing. The user interface is a bit complicated than Rhino, but yes, they have the similar functions in AutoCAD too.
Thank you. Thank you.
And yeah, like I mentioned previously, the tools doesn't really matter if you are using Rhino. Rhino is just it just happens to be the tool of my choice. You can use AutoCAD. You can bring this to Blender. You can bring this to SolidWorks, and it should be the same. In fact, something like a parametric modeling tool like SolidWorks or Pro-E or Creo, those you can actually remove the features because those are built by layers. You can remove that particular feature you don't want to host. It might be easier if you have the expertise to actually do that at that level. So removing the mechanical ribs, for example, is much easier if you have the source files that's in Inventor, for example, because those are built parametrically. So most of the time when it goes to CET, we already have the final step file or DWG file, so we don't really go back to the R&D department or the product design department to actually look for these files. But if your company is tightly knit, that might be a good idea to look at what they are using today, and perhaps it will save a lot of effort and time for you guys. All right, so the second tip is balancing polygons. As I mentioned, when you bring a model into CET, it converts, whether it is a mesh or it is solid, it converts the things to meshes. So to show this, I'm going to use this particular model here. So everything you see here are meshes or polygons, whichever term you like. In CT, if you click on a certain part, you can use this transparency function to only see your selection. You always find the numbers here. If I hit Control A, this is everything. If I select one part of it, this is the triangles of this specific part. And this is a chair, for example. We don't usually have polygon problems with work surfaces and desking because those are much simpler. Chairs is the sittings are the ones that we have the most problem with. So take this for example. Super, because I've done the optimization before, it looks pretty okay. But if I were to run it again, I'm using MK, and if I switch to the high LOD, you notice it looks bad. And high is where you want to put a bit of a emphasis on it. Super and high. Medium is perhaps too far for you to notice, but high is where you are working in real time. Most of the time, at the user's point of view, this is perhaps 80% of what they see is on high. And on Web Configurator, super is 100% of what they see. So you want to work on these two LDs, and of course, that make sure it doesn't look too bad on medium and low. So back to my point, balancing polygons. So this, for example, if you notice, if I select a particular part of it, I have this slider. This is the automatically generated LD using this algorithm, but it doesn't mean that I have to stick to this algorithm. I can select certain parts, which I think can use oak, and you can use this slider to actually improve it. And notice that when I'm sliding this, the green stays green, so I'm still within the budget. And let's use MK. It gives you a different result. So now you can actually compare the two. So let's say if I'm actually happy with 796 and it looks all right for the real-time display, and yeah, let's say I'm happy with this. So technically, if I rerun everything, I've moved from 240 all the way up to, let's type it in, 800. And 800 looks good. So I'm still all right. I'm still in the yellow region, but what I can do is, like I mentioned, balancing it. This is comparatively much more complicated part than, say, this one. This alone, based on the volume and the surface area, Model Lab calculates that it's located 550 for this LED. And this was about 240. So it doesn't make sense, right? This is much simpler. This is the volume that it occupies is smaller, but the details is, there's more details here. So this Model Lab can't really help you here. So you can be the judge of this. And if you're increasing 600 polygons here, let's take away 600 or take away 200 here. I'm just gonna stick with 200. You'll notice this particular shape isn't that complicated, and sliding the triangles around doesn't change it that much. It's not taking a lot away from me. So you can actually allocate the budget here, 500, let's do 250. And perhaps using MK and swirl them. You can add more to this one. So these are things that you can do to basically make this look good. Model that won't be able to tell you that this looks good or bad. It allocates based on the volume as well as the surface area. So I think this is good enough for high. And the same thing with super as well. This is, I've already done this from the original model, so it looks good. But I do have to jump into this and slide it somewhat to basically balance this up. That's same applies to the other models as well. So this on super is 2,300. If I were to slide this, you really don't see much difference. So from 2003 all the way to 203. So there isn't that much different. But based on the size of it, Model Lab is allocating 2,300. That's way overkill. So you can reduce this very much significantly and add it to something that has more details, for example. So let's try this. This is already done. So if I were to run it again, it will switch to something like this. So all these models starts with a very clean model. So the triangles are allocated where it matters. So there isn't that much I can do, except for this ones, for example. I want to bring them up. So these are small parts, and Model Lab always thinks these are small, so it doesn't matter so much. But for us, visibly, it's not so pleasing. So slide it up. You want this, slide it up all the way. And let's see. Oh, I forgot to, let's do that again. Let's take this, is 128 triangles, slide it all the way up. I added about 700. So let's see where I can take away 700. So this was 2003. I mean, for high, it's much lower, but still, I can kind of reduce it. And now I'm in yellow. So let's take this one. That's pretty low already. Perhaps this one, let's do 200. And 400 for this. Maybe, yeah, that's way too low. Yeah, so it's yellow, but it's fine. I managed to add so much more detail to the casters, and without taking too much away from the original budget. So yeah, that's what you want to do when you're doing this. Of course, this is one of the tedious work that you need to do. Batch converter doesn't know where you should put the triangles, so you need a human touch for this one. And yep, but if you start with a nice clean model with all this removed, you shouldn't. I mean, you might still need to go into balancing these polygons, but it's going to be much simpler. So yeah, that would be my second tip: balancing the polygons, and allocate more for what matters, and sometimes usually the simple shapes. If you have a huge cube, for example, whether it's a mini cube or it's a gigantic cube, the polygon you need is 12. That doesn't change really, so you don't really need to allocate that much for simple shapes. So try to optimize it this way. I think with the same polygon budget, you can achieve much more pleasing visuals for sure. All right, so going to third tip, and this is pre-meshing. This will basically answer Dave's question. When you import a solid model right into Model Lab, the Model Lab basically does all the conversion itself, and basically does all the tessellation in Model Lab itself. Tessellation basically means how do you want to convert the faces, the solid faces into triangles, into vertexes, into the polygons. So if you were to pre-mesh it before you import it into Model Lab, it will stay the same number. So let's say if you have a 200,000 triangles model, you bring it into Model Lab, it's going to stay the same. But if you were to have a solid model, which is not based in triangles, you put it in, it will do the conversion. And sometimes we might be overcompensating the meshing. So basically, this happens most of the time at huge curves, like curvatures. It happens like it's too jagged than we would like it to be. So in these situations, I would recommend pre-meshing it. We are working on improving this, perhaps giving a settings so that we have a setting that allows much more triangle when you pull something in that is in solid form. But for now, the workaround would be pre-meshing it. So a good example of this is it's usually like an L table, and you might have a huge curve here. Oops. Yep. So this becomes, when it converts into triangles, it might become way too jagged for it to look good. So this is what is happening. It's taking an approximation, and solids, or rather NURBS, are usually perfect. If it's a curve, it appears like a curve, but it's way too heavy for CET's purposes. And this is what happens. So what we want is a better approximation. Might be higher in triangles, but much less jagged than the ones. So this is what we are working with. But for now, if you can, let me just complete this. So let's make 2 of this. If you pre-mesh it in AutoCAD, in Blender, any 3D software out there, you get a nice one. This is what we are going to bring into CET. So it might be, this is what happens in CET. So basically the setting is way too low. So it looks like this. I mean, this is a bit of an exaggeration, but maybe something close to this. Yeah. So this is the reason we're getting this jagged angles. What we want this, but this is happening. So this is exactly the setting that we want to add in CET. Maybe not exactly in this form, but the same idea. So for now, it's a good idea to pre-mesh it. The advantage of pre-meshing might not just be this. We have way more we can control much better. We can say for this part, it's a simple part, I can reduce it to where it looks optimum, and this I'm just gonna allocate much more triangle to it. When I bring everything to Model Lab, it looks good already. There isn't much I need to do in terms of balancing the polygons in Model Lab. So your CAD environment might be better for you instead of this one, instead of in Model Lab. Okay, so I hope that answers your questions. Dave? All right, so yeah, like I mentioned, pre-meshing does give you better control in balancing triangles. There are softwares dedicated to do this. And yeah, I've included here the AutoCAD guide on converting faces to mesh. You can just Google this or take a print screen of this if you like. It's very easily, it's one of the first search results from Google. Okay, so the fourth one is extreme cases. I wouldn't, this will be much more difficult and it's a high effort, high reward thing. A few things that you can put in is opacity mask. So basically when you have something like this would be a plastic part with a lot of holes. These holes are not exactly removable, nor you'd want to remove them as well. You can use a material to replace it. So this looks like a netting of sort, of a polypropylene netting. If I take this material, you can see that the features are actually built with a opacity mask. So this is a mask that you can build using a graphic editing tool. Just make the part that you want to see through transparent, and you can apply it to your model. I won't go in depth into the step-by-step of doing this because this is gonna take us another hour. So, but this is an option. If you have the expertise to do it, you can always ask for additional sessions after this if you like to know the exact steps of doing this. And there is also the option of normal speaking. So 4 million triangles, for example, this is just off a website. You might have all these details and a simplified mesh. And with a normal map, you can reduce it so much more. But these are for extreme cases and especially organic things like this. Yes, I think we have a question from Tom. If you have 10 more chairs similar to the one you worked on to optimize the models, can you leverage anything that you did from the completed model so you don't have to repeat the same? Oh, yeah. So that's a good question, actually. So a lot of times, due to how many of the manufacturers, especially in United States, they comes from a CIF format, and those models is already pre-built, and you don't really spend a lot of time fixing those. But for new catalogs, I would recommend doing it this way. So splitting them up by type. For example, this is the same exact model that I was showing. For example, you might just need the back and split them up and construct them in Creator. So you just need to do it one time, and you can use this for all the different options and features, and say the drafting chair, it uses the same exact pack. You just need to do it one time, assemble them in Catalogs Creator instead. So technically, yes, you can kind of reduce the work and try to reuse as many models as you can. In that sense, you can also save storage space on the cloud as well. Yeah, but for the steps, if you already have all those models of different configurations, you open them up. Yeah, I would say other than just getting used to the work process, there isn't much that you can leverage. But I would highly recommend assembling all the parts. Like this base might be used in 10 different models because sometimes they are shared components. You can just do that. So instead of doing this 10 times, you just need to do it one time for the same components, share it with the other chairs as well, if they happen to be the same one. So that might not be the case, but if it happens to be sharing, then yeah, that's one good way to do it. So on to the next one. And all right, so my last point. Sometimes it might be easier to just remodel it because it's way too complicated to start with. So sometimes remaking it with the purpose of our symbols in mind might be simpler. A chair that has all these components, and sometimes if it's a legacy model, it presents us with different issues as well. So sometimes just based on the shape of it, redraw something that we're going to use in CET or the web configurator. Yep, sometimes it's easier, I would say. That's definitely the case for some of it.